When you're dealing with an angle of elevation, what is happening is you are standing at a certain point and you're looking up to something else. So when that happens, your line of sight, which is from where you're looking up to the top of what you're looking at, that's going to be your hypotenuse every time. Now from your eyes, you have to draw an angle that's going to be horizontal to the object, and that's going to be a leg. And then straight up creates your right angle, and that's going to be another leg. So the angle of elevation will be between the line of sight and the horizontal from your eyes to the object. I know that's very confusing, but let's go ahead and look at some problems and hopefully it'll make more sense. So it says the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. So here's the fishing boat, and we know that it's going to look up to the top of the lighthouse. Okay, this is going to be your line of sight. Since this is your line of sight, we know it's also your hypotenuse. Now you have to draw a horizontal from where you are to the lighthouse or the object that you're dealing with. Now from the horizontal to the line of sight, this is your angle of elevation, and it's telling us that it's 5 degrees. Now, if the top of the lighthouse is 161 feet above sea level, okay, so that means from here to here is 161 feet. How far is the boat from the lighthouse? So that's going to be your horizontal measurement. So let's ask ourselves, do we have the hypotenuse? Well, the hypotenuse is the line of sight. We don't have the measurement, nor are we looking for it. So that automatically means that I'm dealing with tangent. So the tangent of theta equals the opposite over the adjacent. Well, theta in this particular situation is going to be my 5 degrees, and it equals the opposite, which is 161 feet, over the adjacent, which is x. So to solve, multiply both sides by x, and what you'll have in this particular situation is x is equal to 161 over the tangent of 5 degrees. Again, I got this by multiplying both sides by x and canceling those out, and then dividing by the tangent of 5 degrees to get x by itself. So to figure out the distance from the boat to the lighthouse, I'm going to plug this into my calculator. So let's do alpha x, and we'll do 161 over the tangent of 5 degrees. Okay, let's go ahead and do one decimal place again, as per our habit. We've got 0.23, so let's do 0.2. So x is equal to 1,840 and 2/10. Since we're talking about feet, let's make sure that we put our unit of measure. So that wasn't so bad, was it? On number 12, the angle of elevation from the bottom of a slide. So we have a slide. Here's the ladder. Okay, so the angle of elevation from the bottom of a slide to the top of the slide is 44 degrees. If the top of the slide sits 16 feet above the ground, so from here to here we've got 16 feet. Find the length of the slide. Okay, so that's going to be our hypotenuse. So I know I'm dealing with sine or cosine. Well, let's figure out which one it is, okay? So here's my 44 degrees. 16 is opposite. Of course, this is the hypotenuse. That means we're going to use sine. So the sine of theta, which is 44 degrees, is equal to the opposite over the hypotenuse. So we got sine of 44 degrees equals 16 over x. X is going to be 16 over the sine of 44 degrees. We get that by multiplying both sides by x and canceling out the x's, and then dividing both sides by the sine of 44 to get x by itself. So to find the length of the slide, x, let's plug this into our calculator. We'll have, alpha x, 16 over the sine of 44 degrees. Let's do one decimal place, and we'll get 23.0, which is going to be 23. We're talking about feet, so we'll have 23 feet as the length of our slide. Now I want you to do number 13. All right, talking about angles of depression, that's when you're looking down at an object, but these are a little bit different than the others, okay? So when you have an angle of depression, like here's our lifeguard and here's a swimmer, we're going to be looking down at the swimmer, and that's again going to be our line of sight. When we were looking up, that's the line of sight, and when we were looking down, it's the line of sight. But an angle of depression will make a horizontal from your eyes, and it's going to be outside of your right triangle, okay? So your angle of depression is located right here. Let's see how to use an angle of depression. A fire is spotted from the top of a 125-foot fire tower. So we've got 125 feet for our fire tower. And we are spotting the fire down here. Okay, so this will be my right triangle. Your angle of depression has to come from a horizontal from where you're looking down. So that means our angle of depression is 19 degrees, which is located right here. Okay, so far so good. How far is the fire from the base of the tower? So here's our fire, here's the base of the tower. We're looking for this measurement right here. Okay, so with this, we know that this is equal to 90 degrees from our horizontal. We can do 90 minus 19 to get 71 degrees right here. Then that means if this is 180, 180 minus 90 minus 71 gives us 19 right here. So by alternate interior angles, these two have got to be congruent. So if your angle of depression outside is 19 degrees, you can bring it down. It'll also be the angle inside the triangle. Okay, so to find this measurement, let's figure out if we have a hypotenuse. The line of sight is the hypotenuse, and we don't have that measure, and we're not looking for that measure. So that tells me we're looking for tangent. So the tangent of 19 degrees is equal to the opposite over the adjacent. So once again, x is going to be 125 over the tangent of 19, because we'll multiply both sides by x and then divide by the tangent of 19. So here we'll have 125 over the tangent of 19. Let's go out one decimal place and we'll get 363.0, which is just 363. So x, which is going to be from the base of the tower to the fire, is going to be 363 feet. Number 15, an airplane is flying at an altitude of 8,900 feet over water. So the altitude would be straight up, 8,900 feet. And here's our little airplane. The pilot spots a raft floating in the water. So here's our raft at a 28-degree angle of depression. So looking down, that 28-degree angle of depression is here. Alternate interior angles, we'll put it down here. What is the horizontal distance from the airplane to the raft? So the horizontal distance would be this value right here. So do we have a hypotenuse? Are we looking for a hypotenuse? No. So that means we're going to use tangent. The tangent of theta is the tangent of 28 degrees, and that equals the opposite over the adjacent. So x is going to equal 8,900 over the tangent of 28 degrees. Okay, let's plug that in. Alpha x, 8,900 over the tangent of 28 degrees. So one decimal place will put us at 16,738 and 5/10. So the horizontal distance from the plane to the raft is going to be x is equal to 16,738 and 5/10 feet. Okay, and I want you to do number 16.